This video addresses a situation where a Lutron HomeWorks cable is installed outside of an electrical box and conductors run out from the front opening. It is important to note this method is not standard practice and might not be approved by Lutron or local building codes. Always refer to the manufacturer's guidelines and obtain necessary permits before proceeding. Here's a breakdown of the general steps, assuming this type of installation is permissible after confirming with Lutron and local authorities. Materials you will need include Lutron HomeWorks cable, electrical tape, wire nuts, and a cable clamp or bushing. Firstly, disconnect power. Turn off the circuit breaker or fuse that supplies power to the box where the HomeWorks cable will be connected. Secondly, trim the HomeWorks cable. Cut the HomeWorks cable to the appropriate length so that it will reach the splice point outside the box. Thirdly, strip cable ends. Strip the outer jacket and insulation from the ends of the HomeWorks cable by about 1/2 inch. Fourthly, splice the HomeWorks cable. Connect the conductors of the HomeWorks cable to the wires of the splice using wire nuts or a splice block. Fifthly, insulate the splice. Wrap the splice with electrical tape to provide insulation. Sixthly, secure the HomeWorks cable. Use a cable clamp or bushing to secure the HomeWorks cable where it exits the box through the front opening. This will prevent the cable from being accidentally pulled out. Seventhly, connect the switch conductors. Strip the insulation from the ends of the switch conductors by about 1/2 inch. Eighthly, connect the switch conductors to the HomeWorks cable. Connect the switch conductors to the appropriate terminals on the HomeWorks cable using wire nuts. Ninthly, insulate connections. Wrap the connections with electrical tape to provide insulation. Tenthly, turn on the power. Turn on the circuit breaker or fuse to restore power to the circuit. Some additional notes to keep in mind: ensure that the splice is located in an accessible location outside the box for future maintenance. Use a weatherproof cable clamp or bushing if the splice is located in an outdoor environment. And always follow all safety precautions when working with electrical wiring. It's crucial to emphasize adherence to the National Electrical Code, commonly referred to as the NEC, which provides comprehensive standards for electrical installations. NEC Section 300.14, length of free conductors at outlets, junctions, and switch points, dictates the minimum length of free conductor that must be left at each outlet, junction, or switch point for making connections or splices. Typically, at least 6 inches of free conductor length extending from the box is required. This ensures sufficient wire length for safe and reliable connections. NEC Section 314.16, number of conductors in outlet, device, and junction boxes, specifies the maximum number of conductors permitted in an electrical box based on its size and volume. This regulation helps prevent overcrowding of conductors within the box, reducing the risk of overheating or short circuits. Always calculate the box fill accurately to ensure compliance. NEC Section 110.3, examination, identification, installation, and use of equipment, mandates that electrical equipment, including wiring methods and devices, must be suitable for the intended use and installed in accordance with the manufacturer's instructions. This ensures that all components are compatible and installed safely. NEC Section 312.5, cabinets, cutout boxes, and meter socket enclosures, discusses the proper installation of conductors entering or leaving cabinets, cutout boxes, and meter socket enclosures. It specifies requirements for protecting conductors from abrasion and damage at entry points using bushings or other protective devices. NEC Section 310.15, ampacities for conductors rated 0-2000 volts, outlines the allowable ampacities for conductors based on their insulation type, size, and installation conditions. This section references tables that provide the maximum current carrying capacity of conductors, considering factors such as ambient temperature and the number of conductors in a raceway or cable. Ensuring compliance with these ampacity ratings is crucial for preventing conductor overheating and potential fire hazards. For example, NEC Table 310.15-16, allowable ampacities of insulated conductors rated up to and including 2000 volts, provides ampacity values for various conductor sizes and insulation types under specific conditions. It's important to refer to this table and make necessary adjustments for ambient temperature and the number of conductors in a raceway. NEC Section 300.11 Securing and Supporting Wiring Methods specifies the requirements for securing and supporting electrical wiring methods, such as cables and raceways, to ensure they are properly supported and protected from physical damage. This section mandates the use of appropriate supports, such as cable ties, straps, or clamps, at specified intervals. NEC Section 300.15 Boxes, conduit bodies, or fittings are required, outlines the requirements for using boxes, conduit bodies, or fittings at conductor splice points, outlet locations, switch locations, and terminal connection points. These enclosures provide protection for conductors and connections, preventing accidental contact and physical damage. NEC Section 314.17 Conductors entering boxes, conduit bodies, or fittings specifies the requirements for protecting conductors entering boxes, conduit bodies, or fittings from abrasion and damage. This section mandates the use of bushings, grommets, or other protective devices to ensure that conductors are not damaged when entering or exiting enclosures. NEC Section 300.4 Protection against physical damage specifies the requirements for protecting electrical wiring and equipment from physical damage. This section mandates the use of raceways, guards, or other protective measures to prevent damage from impact, abrasion, or other sources. NEC Section 404.2 Switch Connections outlines the requirements for making connections to switches, ensuring that the neutral conductor is not switched and that all connections are made in accordance with the manufacturer's instructions. This section also specifies requirements for identifying switch terminals and conductors. When working with low-voltage systems, such as Lutron HomeWorks, it is still crucial to adhere to the relevant sections of the NEC and manufacturer's specifications. Even though the voltage levels are lower, safety and proper installation practices are paramount to ensure reliable operation and prevent potential hazards. In low-voltage lighting systems, for example, it is important to properly size conductors to minimize voltage drop and ensure adequate power delivery to the lighting fixtures. NEC Chapter 7 Special Conditions addresses specific requirements for low-voltage lighting systems and other specialized electrical installations. Within Chapter 7, Article 725, Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits provides requirements for wiring methods, overcurrent protection, and grounding for low-voltage circuits. These circuits are commonly used for control and signaling applications, including lighting control systems. Class 1 circuits operate at higher voltage and power levels compared to Class 2 and Class 3 circuits and have specific requirements for wiring methods and overcurrent protection. Class 2 and Class 3 circuits are power limited and are considered safer due to their lower voltage and current levels. The NEC provides guidelines for selecting appropriate wiring methods and overcurrent protection devices for these circuits. NEC Section 725.52 Wiring Methods and Materials on Supply Side specifies the requirements for wiring methods and materials used on the supply side of Class 2 and Class 3 power sources. It mandates the use of listed Class 2 or Class 3 cables or wiring methods suitable for the voltage, current, and environmental conditions. NEC Section 725.55 Wiring Methods and Materials on Load Side outlines the requirements for wiring methods and materials used on the load side of Class 2 and Class 3 power sources. It permits the use of specific types of cables and wiring methods, provided they are suitable for the application and installed in accordance with the NEC. NEC Section 725.121 Overcurrent Protection specifies the overcurrent protection requirements for Class 2 and Class 3 circuits. It mandates the use of overcurrent protection devices, such as fuses or circuit breakers, to protect the circuits from overloads or short circuits. The size and type of overcurrent protection device must be selected based on the circuit's voltage, current, and wiring characteristics. NEC Section 725.130 Wiring Method specifies the wiring methods permitted for Class 2 and Class 3 circuits. It outlines the types of cables, raceways, and wiring methods that are suitable for use in these circuits. Common wiring methods include Class 2 or Class 3 cables, listed communications cables, and specific types of flexible cords. Proper grounding is crucial for electrical safety in both high voltage and low voltage systems. Grounding helps to minimize the risk of electric shock by providing a low impedance path for fault currents to return to the source. NEC Article 250 Grounding and Bonding provides comprehensive requirements for grounding and bonding electrical systems and equipment. NEC Section 250.4 General Requirements for Grounding and Bonding outlines the general requirements for grounding and bonding electrical systems, including the connection of grounding electrodes, equipment grounding conductors, and bonding jumpers. It emphasizes the importance of establishing a low-impedance ground fault current path to facilitate the operation of overcurrent protection devices. NEC Section 250.24 Grounding Service Supplied Alternating Current Systems specifies the requirements for grounding service supplied alternating current systems, including the connection of a grounding electrode conductor to grounding electrode system. This ensures that the electrical system is effectively grounded to earth, minimizing the risk of electric shock. NEC Section 250.92 Services specifies the requirements for bonding service equipment, such as service enclosures, meter enclosures, and service raceways, to ensure electrical continuity and minimize the risk of voltage potential between different metal parts. Bonding jumpers are used to connect these metal parts together, providing a low impedance path for fault currents. NEC Section 250.96 Bonding Other Enclosures specifies the requirements for bonding other enclosures, such as electrical boxes, cabinets, and equipment enclosures, to ensure electrical continuity and minimize the risk of voltage potential. Bonding jumpers are used to connect these enclosures to the equipment grounding conductor, providing a low impedance path for fault currents. When installing electrical equipment, it is essential to follow the manufacturer's instructions and recommendations for grounding and bonding. This ensures that the equipment is properly grounded and protected from electrical faults. Always consult with a qualified electrician or electrical engineer if you have any questions or concerns about grounding and bonding requirements. Remember, electrical work can be dangerous, and it is essential to take all necessary precautions to protect yourself and others from electrical hazards. Always work with a qualified electrician or electrical contractor to ensure that electrical work is performed safely and in accordance with NEC and local codes. In addition to the NEC requirements, local building codes and regulations may also apply to electrical installations. These codes may vary depending on the jurisdiction and may impose additional requirements or restrictions on electrical work. Always check with the local building department or authority having jurisdiction to determine the applicable codes and regulations. Obtaining the necessary permits and inspections is also crucial for ensuring that electrical work is performed safely and in compliance with the codes. Permits are typically required for most electrical work, including new installations, alterations, and repairs. Inspections are conducted by qualified inspectors to verify that the electrical work meets the code requirements and is safe for use. Failure to obtain permits and inspections can result in fines, penalties, and potential safety hazards. Before starting any electrical work, it is essential to plan the installation carefully and consider all relevant factors, such as the load requirements, wiring methods, and environmental conditions. Develop a detailed wiring diagram or schematic to guide the installation process and ensure that all connections are made correctly. Select appropriate materials and equipment that are suitable for the intended use and comply with the NEC and local codes. Ensure that all tools and equipment are in good working condition and that you have the necessary personal protective equipment, such as safety glasses, gloves, and insulated tools. When working with electrical circuits, always de-energize the circuit before starting any work. Use a voltage tester to verify that the circuit is de-energized and to confirm that there is no voltage present. Follow lockout-tagout procedures to prevent accidental re-energization of the circuit while you are working on it. Make sure to communicate effectively with other workers and occupants in the area to ensure that they are aware of the electrical work and the potential hazards. Keep the work area clean and organized to prevent accidents and ensure that you can work safely and efficiently. After completing the electrical work, thoroughly test the installation to verify that it is functioning properly and that all connections are secure. Use appropriate testing equipment such as a multimeter or circuit tester to check for voltage continuity and insulation resistance. Correct any deficiencies or problems that are identified during the testing process. Document the electrical work that was performed, including the wiring diagrams, materials used, and test results. Keep these records in a safe place for future reference. Consider documenting with photos or videos as well. By following these safety precautions and best practices, you can minimize the risk of electrical hazards and ensure that electrical work is performed safely and in compliance with the NEC and local codes. Remember, electrical safety is everyone's responsibility, and it is essential to prioritize safety in all electrical work. Finally, if you're unsure about something, consult with a qualified electrician.